Hello, today I will prove Cauchy function for every rational number that f p over q will be always p over q times f1. The f1 may be any number, any constant number c. Cauchy function is a function where we know that fx plus y equals fx plus fy. At first, try to prove this for every natural numbers, positive integers, like if we know that f1 equals c, now insert x equals y and equals 1. So f2 equals 2 times f1. So this must be 2 times c. And now by using induction, we can see that fn plus 1 equals fn plus 1 plus f1. And if we know that fn was n times c, n was positive integer, we can see that fn plus 1 must be n times f1 plus f1. So this number must be clearly n plus 1 times f1. So by using induction, we have proved that this is correct, that for every positive integer fk, it will be k times f1. Now let's see why f0 equals 0. If we insert x equals y and equals 0, we get that f0 equals 2 times f0. So from here we can conclude that f0 must be 0. Now by using this one, we can see that this function must be odd. Like if we take fx plus minus x, this must be equal fx plus f minus x. Clearly this is f0, so this is 0, and we get that fx equals negative f minus x. So if we know that for every positive integers fk equals k times f1, we can continue from this, that fm equals m times f1. The m is any integer. It has no matter it will be positive or negative. M must be any integer. And how can we prove this for every rational number? Now let's first discuss that we can see that fn times x, this must be n times fx. And how can we prove this? Now we can use induction once again. Fx plus x, this clearly equals 2 times fx. How? By using the fact that clearly this is f2x. Let's assume that we know that for every k, fk times x equals k times fx. K must be also positive integer here. K must be positive integer. So what can we say about fk times x plus x? This number must be fkx plus x fx. So by using induction step, we can see that this equals k times fx plus fx. So this is k plus 1 times fx. Now we can see that we have finished this induction step, and we have proved that f times nx equals n times fx for every number, every positive integer n, and every number x. X is any number, any real number, and n is any positive integer. Now if someone has given any rational number, we can write this in terms of p over q, f p over q. Then now we need to find what will be f over pq, f p over q. To find this one, we need to take f q times p over q. Clearly this number equals f of p, and because p is integer, we can see that this equals p times f1. But in another case, we can assign this number as x, and q will be n in our case, because this must be positive integer. we assume that denominator is positive. Now we will get that this equals q times f p over q. Now if we combine these two equations, we can see that p times f1 equals q times f p over q. So if we divide both sides by q, we get that f p over q equals p over q times f1. And this was all we wanted to show, that for every rational number we can represent this as p over q times f1. The f1 is some constant number. See, for the general case, we know that Cauchy equation has a lot of solutions if we don't have some restrictions about the boundaries of this area, or we don't know, or we know any additional information about increasing or monotonous function. So if you are interested in the Cauchy function, please write in the comments, and I will try to explain this more clearly. And please don't bother to like and subscribe my videos.